Good morning, everybody. All right, so in the last lecture, we were in the streams notebook. So let me just quickly give you a recap of last lecture. So remember in Unix tries to treat all information the same way, right? So all information in Unix, well, not all, almost all information in Unix is considered to be just a stream of bytes, right? And this includes files, right? So a stream of bytes just means it's a sequence of bytes, right? A sequence of zeros and ones, right? So if everything is just a stream, then you need a way to identify what stream you're working with. So Unix calls those file descriptors. Right? You have the three standard file descriptors, standard input, standard output, and standard error. The file descriptor is just an integer number. I think it has to be a non-negative integer number. So standard input, that's just normally, that's connected to your keyboard, right? Standard output is normally connected to one of your terminals, and standard error is also normally connected to one of your terminals, right? So those are the three standard streams that you can use anytime. If you open a file for reading or writing, that also creates a stream. So that opened file also has a file descriptor. Okay, so we were just at this point here where we're about to talk about, can you send the output or can you get input from somewhere else, right? So a user can change where a command gets its input from or sends its output to, right? And that's called redirection. Okay, so normally a program that's running in your terminal that's running in your shell will output information to the terminal connected to the shell. So that sends stuff to standard output. Right? Now, if you want to, you can redirect standard output to go somewhere else. Right? And the way you do that is anywhere in your command. This is the weird part. You can put this anywhere in the command. Most people put it at the end, but you don't have to put it at the end. You can put it wherever you want. You put in the following text. Right? You write 1, no space. Right? Then the greater than sign, and then the name of the file where you want to direct the output to. Right? And so this will take whatever command, whatever output it generates. Instead of sending that output to the terminal, it says redirect standard output, which is file descriptor number 1. Right? Redirect that output to the file called output file name, or whatever file name you choose. Right? So that 1, that's the name of the file descriptor that you want to redirect. Right? The greater than, that's redirecting output. Right? That will create a file having that name. If it doesn't exist, and that file will contain the contents of the output generated by the command. If the file exists, it overwrites that file. Right, now, you've actually seen this before. So in an earlier lecture, I showed you how to redirect stuff to a file. Right? We didn't use the 1. So redirecting standard output, you can just use the greater than sign. The 1 is optional. So where to go? Somewhere it's in here. Where to go? Oh, here it is. So when redirecting standard output, the file descriptor is optional. Right? So if you leave the file descriptor out, then it assumes you're redirecting standard output. Right? And so here are some examples of using that. Right? So here's your command. Right? So I'm going to list the contents of a directory. There's my command, ls minus big A. Right? So list all the files in a directory, including the hidden files, but not including dot and dot dot. Right? So remember, big A is almost all. Right? Send the output that would normally go to standard output to the file files.txt. Right? And so if you run this, the output of ls doesn't go to the terminal anymore, right? So you get no output. Right? Remember, if you delete that and run ls, well, now you get output. Right? But when you redirect, when you redirect that output to a file, right? You're sending what would normally go to standard output to the file, so you get no output on standard out. Right? And now you can, if you cat the contents of files.txt, right, you'll see that you get the listing of the files in the directory. Right. This is another, you may have noticed that the output doesn't look the same as what appears in your terminal. Right? So if you run ls in your terminal, right, by default, it doesn't print everything out it doesn't print the files out one at a time, right? It tries to fit the information onto a screen somehow using some algorithm, right? If you redirect the contents to a file and then look at the contents of the file, you'll see that all the files appear as a separate line, on a separate line. Right? So there's a slight difference between how ls generates its output when it sends it to a terminal as opposed to when it redirects to a file. Okay, so any command that sends output to standard output, you can redirect that output to you can redirect it to a file, right? So cowsay, right? There's my cowsay command, right? That generates output. I'm going to try this and see what it does. Right? So that generates that output there, right? If you redirect it to a file, right? No output. Instead, the output went to the file mu.txt. Right? Also, in a previous lecture, you saw that you don't have to use just the single greater than sign. Right? You can use the double greater than sign to append instead. Right? So the double greater than sign redirects and appends. Right? The single greater than sign redirects and overwrites or creates if necessary. Right? The double greater than sign will also create if necessary. Right? So if you don't want to overwrite, use the double greater than. Right? If you want to overwrite, use the greater than. And you don't get a warning in either case. Right? So in either case, whatever file you say you tell it to do the redirection to will get written to. Okay, so redirecting any output stream works the exact same way. Right? You specify the file descriptor, you use the greater than sign or the greater than sign twice to append. Right? And that redirects that particular output stream to a file. Right? So to redirect standard error to a file, you just specify output stream number 2. Right? And away you go. So ls will generate an error message if you ask it to list information about a non-existent file. Right? By default, that message goes to standard error, which is connected to your terminal. Right? If you don't want to see that output, right, just redirect it to error.txt, for example. Right? Now there's no error message and there's no other output at all. Right? If you look inside error.txt, right, there's where the message is. If you redirect the wrong stream, right, so if I redirect standard output instead of standard error, right, you now get the standard error message being sent to its default location, right, which is the terminal, right? So that redirects the output of that redirects standard output to error.txt, but there was no output to standard out, right? So when you look at the contents of error.txt, there's nothing there, right? If this generates an error message, then you want to output, you want to redirect the standard error stream. Was there a question over here? I thought I saw a hand. No. Okay, so you might ask, can you do both, right? So can I take standard output and redirect it somewhere? And can I take standard error and redirect it somewhere all at the same time? Somewhere else at the same time, right? So this ls command, most of the shell commands do not stop running if they encounter an error, right? In a lot of the programs you've written in first year, either in 121 or 124, right? If your program encounters an error, typically it stops. Right? But that's not the way most bash commands work. Right? If a bash command encounters an error and there's still more work for it to do, it just keeps on going. Right? Usually you'll get some sort of error message, right? But otherwise it keeps on processing its inputs. So here's ls. Right? So this command is this command is listing information about the file zzz, which doesn't exist. Right? And all files that start with the word file and have 2 more characters after file. Right? So file 01, file 02, file 03, and so on and so on and so forth. ZZZ doesn't exist. So you might think that this prints out an error message saying ZZZ doesn't exist, and then it stops, but it doesn't, right? It tells you it can't find the file ZZZ, but then it keeps on processing all the rest of the files, right? So anything that matches that pattern, it's still information about that, so ls still lists that file. Okay, so what that means is that a command can generate output to both standard error and standard output, right? And it's not unusual for it to do so. So if you want to, you can redirect both streams to different locations. Okay, so there's my command again, right? I would like to redirect standard output to files.txt. So there's the redirection of standard output to files.txt, right? And I would like to send the error output to error.txt, right? So there is the redirection of stream 2 to error.txt. Right? So run that, right? No output because all the output got redirected somewhere. Right? Files.txt contains a listing of all the files that match the pattern, right? And error.txt contains the error message, right? So you can redirect as many output streams as you want each to a different location. All right, now what happens if you really want all the output and you want it all in the same file, right? So can I redirect multiple output streams to the same location? And the answer is yes, you can do so. Right? So if I would like to redirect both standard error and standard output to the same place, then you use the funny notation 2 greater than ampersand 1. Right? The syntax is weird, but that's just the way it is. Right? So to read this, what's happening is the 2 greater than, right? So that's redirecting standard error. Right? So the 2 is standard error. The greater than sign is the redirection operator. Right? The and 1, right, means duplicate whatever the output stream standard, duplicate the stream corresponding to file descriptor number 1, so that's duplicate standard output, right? And copy that to stream number 2, right? And so what happens now is that standard error gets redirected to wherever standard output is going, right? So duplicate file descriptor number 1 and copy it to file descriptor number 2. So wherever you send standard output, that's also where standard error is going to go. All right, so here we go. There's my command. Right? I'm going to redirect standard output to files all output.txt, right? And I'm going to redirect standard error to wherever standard output is going to. Right, so one more time, there's my command. Right, redirect its output, its non-error output, to that file. Right, and then take whatever the error output is and send that to wherever I sent standard output to. Right. So run that. No output on your terminal because you're redirecting all the output somewhere else. Right. Now look at the contents of files all output.txt, and you'll see the error message or messages, and the listing of all the files. Right, so there's actually 2 redirections happening here. Right, the first one is there. Right, the second one is there. Right, and so you might ask the question, does the order matter? And the answer is yes, the order matters. Okay, so if you have multiple redirections on the same command, then the redirections get processed from left to right. Right? So in this case, that redirection gets processed first. That redirection gets processed second. So if you flip the order of them, right, that gets processed first. Right? So that says redirect standard error to wherever standard output is going. Right? But I haven't redirected standard output anywhere, so that's just going to go to the terminal. Right? This says redirect standard output to files all output.txt. Right? And so what ends up happening here is that the error messages end up going to the terminal, right? And then the regular output ends up going to the file. So if you run that command, you get the error message on the terminal. And in the file, you do not get the error message, you just get the regular output. Right? So the order matters if you're redirecting more than once. Right? It gets, you have to remember to write them in the correct order, left to right. Okay, you can also redirect standard input, but you almost never do this. It's very unusual. Right? If you have a command, if you have a command that's supposed to read something from a file and you would like to redirect, if you have a command that reads something from the keyboard and instead you want to send the contents of the file to that command, then this is when you'd want to do this. However, most of the bash commands that you would use normally aren't reading from the keyboard by default. Right? Most commands want to read from a file. So it's a little bit unusual that you would do this. Right? If you want to do this, right, then you use the less than operator to indicate that you are redirecting standard input, or you're redirecting an input stream, Right? So 0 less than input file name means redirect standard input. Instead of taking standard input from a keyboard, take it from the file input file name. Right? So sort is one of these commands that can read from standard input. Right? So you could, if you really wanted to, write that. Right? So that says sort the contents of unsorted.txt. Right? Because sort will also read from standard input. Right? But sort, by default, reads from a file. So normally you would just write sort unsorted.txt. Right? It's very unusual that it's somewhat unusual that you redirect standard input. But you can do it if you need to. Okay, any questions about redirection? Super. Okay, so we've seen pipelines very briefly before, right? So if the analogy that was given at the beginning of the notebook, where's my scroll bar? So remember, this is our analogy of a command. Right? So a command you can think of as just being a single section of pipe, right? Flowing from the left, there's some input. The command typically produces some output, right? And so you can hook up sections of pipe, right? So that each command takes as input the output from the previous command, right? And this is called a pipeline in Unix. Right, so commands have inputs and outputs, so it's a natural question to ask, can I hook up the input to the output from another command? Right? The symbol you use to do so is the vertical bar. Right? So the vertical bar connects the output of one command to the input of the next command. Right? So that little pair of commands there, right, says run the fortune command. Take the output of fortune and send it to cowsay. Right? Cowsay takes that as input and then does something and then sends the output to standard out. Right? So in a picture, that's what you get. Right? You get two sections of pipe hooked together. Okay, if you're listing the contents of a giant directory somewhere, and so sometimes you have very large directories, directories with lots of files, right? It's often useful to be able to look at the output one screen at a time. Right? That's what the less command is for. There's also a more command. They both do something similar. Right? They let you look at output. They let you look at text one screen at a time. Right? So I can run this command in my. I'm not going to run it in Jupyter because it's very clunky in Jupyter. Right? So if I do ls root bin, there's a lot of files. Right? So if I scroll up, you can see there's many, many files. So if I want to interactively look at the output, right, I can list the contents of the directory, but then I can send that output to another program that lets me process the contents one page at a time. Right? So more or less will both work here. Right? So if I send it to more, right, you get the output of ls one page at a time. Right? And now you can go through that interactively like that. Q will quit. Both more or less, they work in similar but not exactly the same ways, right? So Q will quit that Less is actually the program that man uses to display the contents of a man page. And you can hook up as many of these commands as many commands as you want into a pipeline, right? So a pipeline can have an almost arbitrary length. There is some fixed upper limit, but it's typically much larger than you would normally use. Right. Okay, so here I can list the contents of two different directories. So I can list the contents of bin, and I can list the contents of root user bin. Right? I can send its output to the sort command. Right? So I can sort all of the files in alphabetic order. Right? And then I can take all of that and send it to less or more. Right? So there's a 3-command pipeline. Right? And I guess we'll just type that into the shell, and you can see what it does. So root bin, root user bin, pipe that to sort, pipe that to sort, and then pipe that to less or more. Right? So when you do that, you're going to see that there's duplicated file names. Right? And so you can see that both directories contain the file named 223-2.7, right? They both contain NF, and so on, and so on, and so forth. Right? It is the case that root bin and root user bin are basically duplicates of one another. All right, so what happens if I want to know how many files are actually in those two directories? Right. So WC is the command called word count. So let's just, I don't remember if I asked you to use this on the assignment one. So WC will print the number of new lines in a file, right? So basically the number of lines, right? The number of words in a file, right? Or the number of bytes in a file, which in a typical Linux environment, that's the number of characters in the file. Right? So to list the number of lines, it's WC minus L. Right? To list the number of words, it's WC minus W. Right? If you want the number of characters for some reason, that's WC minus C. And there's some other options as well that you can look at. Right? So I'd like to know how many files are in the two directories bin and user bin. Right? And so you could run the command ls bin, send it to sort. Although you don't have to send it to sort in this example, word count, number of lines. Right? Now remember bin, root bin is the directory that contains many of the commands that are known to my operating system. Right? You see there's 2,379 commands. This was done on a different machine. Okay, also notice that the output, sorry. Let me just show you the output again. Right, notice that there's lots of duplicates when you do this, right? So if I would like to know how many unique file names there are in the two directories, you can use the unique command. So uniq is the command that counts the number of unique occurrences. However, you have to be a little bit careful with unique. Unique, so report or omit repeated lines. So it'll either tell you how many unique lines there are, or it will tell you how many duplicated lines there are. There's a command line option for both. So what you have to remember is, here we go. There's a note. Why this is at the bottom, I don't know, because this really should be at the top. Right? It warns you, so unique does not detect repeated lines unless they are adjacent. Right? And so in other words, what this means is unique expects its input to be sorted. Right? Otherwise, it won't correctly count the number of unique occurrences. Right? If you think about why it works this way, it's because of computational efficiency. Right? If you have an unsorted list of, an unsorted sequence of lines, then to count the number of unique lines, it's O(n) squared in the number of lines, right? So if you're processing a large file, that's going to take a long time to run. So unique assumes that you've sorted the input before you try to count the number of unique lines. Right, so don't forget to sort if you're going to use unique. Right, so I'd like to know how many unique lines, unique file names there are. Right, I can just run this command again. Right, so list the contents of the 2 directories. Right, send that output to sort. Send the output of sort to unique, and then send the output of unique to word count. Right, so there's 1,191 unique commands on my in the 2 directories. Right. If you want the number of duplicated file names in the 2 directories, you just ask unique for the number of duplicated lines. Right, so that's -d. Right, again, to detect the duplicated lines, the input has to be sorted. Right, so if we change, we just add the option -d to unique. Right, there's 1,188 unique files. Right, if you sum those 2 values, you should get the previous value of all the file, the previous count of all the files. Right, or something close to it anyway. Right, so you can chain as many of these commands as you want together into a pipeline. Yeah.
Does a unique -d preserve every copy of the duplicated file?
Does it preserve every copy? It tells you the number of lines that are duplicated, assuming that the lines have been sorted. Okay. Yeah. What else did it do? Sorry, I had. Oh, right. Now, if you look at the sort command, if you scroll through its options, there is somewhere, reverse, compress, debug, merge, output, key, save, there. Right, the sort command can also count the number of will generate. You can ask sort to generate only the unique lines in a file. Right, so you could also use for some of these problems, you can get rid of the command unique itself and ask sort to do the work for you. Right, so it says with -c, check for strict order. Right, sorry, without -c, output only the first of an equal run. Right, so in other words, only output the unique lines. Right, so sort can also do this. All right, so that's what happens if you want to hook everything up into a nice long sequence of commands, right? Where the output of the previous command goes to the input of the next command. Right? Okay, so just like any pipeline, though, it is occasionally useful where you want the output of a command to go down the rest of the pipeline, but you also want a copy of the output of a command to go somewhere else. Right? So redirection lets you send the output of a command to a file. Piping allows you to send the output of a command to the input of another command, right? And so the answer, so the question is can I do both, right? So can I redirect the output somewhere, right, to a file, right? But can I keep on sending that output down the rest of the pipeline? Right? The answer is yes. So there's something called a T in Unix, right? So the T is actually a command, right? So the command T, right, takes some input, and it just copies the input to its output, right? So that input goes directly to the output, right? But it also sends a copy of that output to a file, right? So it redirects the output, it redirects its input to a file, and it also passes the input to the output of T itself, right? So this input here goes out here, and it also goes to some file, right? So why would you want to do this? So sometimes it's useful to take an intermediate result of a pipeline and save that to a file, right? It's not often useful. It's not that often that you want to do this, but it's sometimes useful. Right? So for example, I might want to, the date command will print out the current date, and it prints it out in some format. If you're on a Mac, these examples won't generate the exact same output as what I'm going to show you. Right? So the default date command on Mac is different than the date command on Linux. Okay, so date on my computer produces that output there, right? So Tuesday, September 19th, it gives you the time in the year. It even gives you the time zone, right? If you look at the documentation for date, you'll discover that you can change the output into almost whatever format you want. Right? Okay, so I would like to save the output of date to a file, right? So to do that, right, if I wanted to save it to a file, I would just use a redirect, right? So I'll redirect that to full date. Whoa, like that. Right? But when I do that, I don't get the date printed to the screen. Right? If I want to do both, then that's where T comes in. Right? So if I run the date command, pipe the output of date to T, right? T will print whatever date gave it, but it also redirects that output to the file fulldate.txt. Right? So it generates the output. But if you look at fulldate.txt, the output is also there. Okay, so there's that command again, right? There's our T. Now I'd like to take whatever the full date is, right? And I would like to take that output and only print out the day. So let me run this first, and then I'll explain what's going on. Right? So now the output is the day Tuesday. Right? The contents of fulldate.txt, they're still the same as before. Right? Right? Why is it the same as before? Because T takes the output of date and sends it to fulldate.txt. Now it passes that output down to cut. Right? So what does cut do? Cut removes sections from each line or of files. Right? So this will process an entire file and remove parts of each line. Okay. So what cut does is it prints selected parts of lines from each file to standard output. So basically what cut does is it looks for delimiters in a line. Right? By default, the delimiters are spaces. Right? Everything that's not a delimiter is called a field. So by default, if I pass this to cut thinks that the first field is Tuesday, the second field is September, the third field is 19. The next field is all of this, right? The next field is the time zone, and then the last field is 2023. Right? So using cut, I can pick which fields I want to display. Right? So here, right, I'm actually explicitly specifying that the delimiter should be the space. Right? And I only want to see the field number 1, right? Which is the first field, right? So cut starts counting at 1, it doesn't start counting at 0. Right? So this thing here says, run the date command, right? Send the output of date to fulldate.txt, send the output of date to the cut command, right? And the cut command, use the cut command to only print out the first field of the output. Right? So we get Tuesday being printed out. Fulldate.txt is still the full date. Right? Okay, so those are the long format options. If you want the short format options, which are easier to type, right, the equivalent command is that. Right? So -d specifies the delimiter. Right? -f picks the field. So if I print the third field, that's just the month. Right? Sorry, that's the third field, sorry. The third field is 1, 2, 3, sorry, that's the day. Did I print them? Print the day. Okay, so this is the... Okay, I'll have to fix that. The fourth field is just the, oh, that's wrong too. I wonder if this is, never mind. Is the time. Okay. So T is just a command, right? So it's not an operator like the vertical bar is. And that means you can stick it anywhere in a pipeline, right? So you can grab the output from any one of your commands that are in a pipeline and send that output to a file of some kind. Right? So I can run the fortune command. I can save the output of fortune command to fortune.txt. I can also take the output of fortune and send it to CISC, right? I can take that output and send it to cow.txt, and I can also take that output and send it to CISC a second time. Right? What is it going to do if I run it in the terminal? Okay, so if you run that, right, you get a fortune, so there's your fortune, right? A long forgotten loved one will appear soon by the negative. Right? That output gets sent to fortune.txt. So what's in fortune.txt? Right? So that's the fortune. Right? We take that output and send it to CISC. Right? So that's the first cow, that part there. Right? That output gets sent to cow.txt. So if we look at cow.txt, right, there's your cow, right? That output gets sent to CISC yet again, right? And so there's your second cow. There's your second instance of the CISC program. Right? I don't remember what -n does. Man CISC. Okay, so now CISC is an example of a very badly written man file because it doesn't list the options in any useful way. It's in here. Oh, here it is. If -n is specified, there must not there must not be any command line arguments left after the command switches have been processed. Well, let's take it out and see what happens. I forget why it's here. Oh, it fixes the line wrapping problem. That's what's going on. Okay, so that's why your -n is there, so that it actually generates the output in a nice way. All right, so that's all I wanted to talk about for streams. I guess we'll move on to the next notebook. Does anybody have any questions about writing a pipeline or anything else I talked about today? Redirections? Okay. So the next notebook is the introduction to what are called expansions. And you've seen some of these expansions or substitutions before. Right, so you've seen, I told you about tilde expansion. Right, so remember that tilde, this symbol here. Right, we say that tilde expands to the name of your home directory. Right, now what you have to remember, so what's really useful to remember right now, is that anything called a substitution or an expansion in bash means that thing called a substitution or expansion in bash gets replaced with whatever it expands to, right? So the tilde expands to the name of your home directory, right? So literally what happens is your shell takes the tilde and replaces it with the name of your home directory, right? So that on my computer, that will get replaced with that there. Right? So that gets transformed into that, right? And that's why it's called an expansion or substitution, right? The shell literally takes the value that's produced by the expansion or substitution and sticks that value in for the expansion or substitution, right? So there's 7 of these in bash. Which is a little annoying because it's hard to keep in mind exactly what all of these things mean and exactly what order they happen in, right? Because they all happen in a specified order. right? So the order in which expansions happen is the order that they're shown here. Right? 4 and 5, these have the same precedence, right? So they happen in the same order. So in other words, so if they happen in the same command, they get processed left to right. Right? So we haven't seen many of these, right? So we've only seen tilde, we've seen word splitting, and we've seen file name expansion. Right? File name expansion is what happens when you use star or question mark as a wildcard character. Okay, so I need to be here, which is fine. Okay, so starting at the top, there's something called brace expansion. Right, so brace expansion is a sometimes used mechanism for generating patterns of words. Right? It's not super useful. Occasionally, though, it can make your life a little bit easier. So a brace expansion uses braces, not surprising. Right? You're allowed to put a string in front of the opening brace, and you are allowed to put a string after the closing brace. Right? So pre is called the preamble, post is called the postscript. Right? And inside the brace, you have what's called an expression. So an expression is just a series of comma-separated strings, or it's a sequence expression. So I'll explain what all these are in just a second. Right? So when this expansion, every string generated by this expansion starts with pre, right, the prefix. Every string generated by the expansion ends with the postscript. Right? Then the expression in the middle generates the part in the middle of the string. Okay, so here's an example of a brace expansion. Right, so this is an expansion that has no prefix or postscript. Right? So if you have a brace expansion, then all of the strings separated by commas, they all appear as a separate string in the output. Right? So this generates the list of strings, A, then B, then C. Right? It uses the space as the default separator. Right? So as far as bash is concerned, that's actually a list. Right? That's a list of strings. All data in bash are strings. Right? So if you have multiple strings on the same line, that's as far as bash is concerned, that's what's called a list of strings. Right? So that expansion there just produces the string, the list ABC. Right? If you have a prefix, right, then that prefix appears in all of the generated strings. Right? So every generated string has before underscore. Right? So there's the second before underscore, and there's the third one. Right? If there's a postscript, all of the strings include the postscript at the end. Right? So all of the strings include underscore after at the end. Right? And then this stuff in the middle, right, it produces one string for each one of those strings in that comma-separated list. Right? So you get before underscore and underscore after, before underscore, ampersand, underscore after. Right? Ampersand is special, so you have to escape it. Right? So that's why the backslash is there. Right? And then before underscore also, underscore after. Right? So you get those three strings there. All right, you can also generate sequences of strings. So the sequences are specified with this syntax here. Right, so it's x dot dot y dot dot increment. Right, so x and y are integers, are single characters. Right, and increment is the optional step size, right, which is also an integer. So 0 dot dot 9 inside a brace expansion. Right, you have to remember this is inside a brace expansion. So you have to remember that this is not necessarily valid somewhere else. Right? So to generate a sequence, you don't always, in a brace expansion, you write it this way. If you try to write this outside of a brace expansion, you're likely not going to get the result you expect. Right? So 0 dot dot 9 just means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Like that. You can go backwards. And the expansion mechanism is smart enough to know that you want to count down. Right, so 9 dot dot 0 will count down. Right, if you want to count in increments not equal to 1, That's what the second dot dot is for, right? So that counts from 10 to 20 in increments of 2, like that, right? And letters are just, Bash treats those as though they were just numbers, right? I guess, yeah. So A dot dot G is A through G, like that, right? If you want to go in steps of 2, you can go like that, right? Now the problem with the brace expansion is that you have to be a little bit careful about your ranges because not all ranges are well defined, right? So I have no idea what A dot dot big A does, for example. Right, so I have no idea what that means. Let's try it and see what happens. So you get something bizarre, right? And so the output of these expansions, so don't try to get fancy with these expansions, right? Just try to keep it simple because otherwise the output is unusual. Right? So for example, I would never guess that it would generate that, but apparently it does. Right? Okay, so what are these useful for? They're not super useful, to be blunt. Right? Occasionally, right, you might want to generate a sequence of files or directories that have a name, that have names that actually follow a sequence you can generate with a brace expansion. Right? So for example, you might generate directories for certain years and certain months of the year. Right? So I've got a directory 2019-01, so presumably that's the directory for January 2019. Right? And then 2019-02, and then 2019-03, all the way up to 2022-12, right there. Right? And so there's an example of using a brace expansion to generate a whole sequence of directories. Right? Now remember, why does this work? Right? Because those two expansions, right, they get replaced with the strings that they generate. Right? Remember, every expansion gets replaced with its output, right? So this here, right, that expansion there ends up being, when the shell interprets it, right, it ends up generating 2019, how am I naming these? 01? Right, 2019, I'm actually not sure what the order is, but I'm going to go with this. 2019-03, dot, 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 dot. Right? So that little expansion there literally gets substituted with this giant list of strings. Right? That list of strings gets passed to makedir, and makedir generates all of those directories. Right? So there's another example here. Right? I can use touch to generate a bunch of files. Right? That'll generate the files 000102 up to up to file 30. Right? So again, notice that it's smart enough to know that 00 actually means 0. Right? And that you want to generate the a 2-digit sequence of names. Right? So in other words, it's smart enough to generate 000102, which is actually kind of impressive. All right, and so I guess we'll call it quits there, and we'll introduce the other 6 expansions in the next class.